So as Jeff said, he gave me a phone call one day and said, Justin, come to DARPA and change the world. We're doing this every day, and it's a remarkable experience, a remarkable place. 5 years ago, when Jeff was working on the Revolutionizing Prosthetics program, he indeed did that, right? There's a person that was able to achieve near natural upper extremity control just with their brain, okay? This completely transforms the way that we think about our physiology interacting with machines. Now, Jeff claims it's a little kludgy, and maybe it is, because it's the first generation of these kinds of machines. But nonetheless, it demonstrates how if you get physiology out of the body, what you can do with it. It shows what you can do with it. And for Jan, this person who is completely paralyzed, this means the world to her. This opens up the world to her. Now, what does that mean for the rest of us? Okay? This is the part that we really need to think about a little more deeply. Okay? The way that you and me interact with machines is profoundly different. All of us have experienced this here, right? Working with your computer, it doesn't do what you want it to do. You get frustrated, and you just want to punch straight through the screen, right? So we're asking, what are we going to do about this, right? How are we going to change this dynamic between humans and machines? Now, it's quite interesting that this is not the place where we started, okay? J.C.R. Licklider, he was a DARPA office director of the Information Processing Techniques Office, one of the forefathers of the internet, and he had a very different idea when it came to our interaction with machines. He thought that in the very near future, we had a very tight coupling with these machines, right? This relationship that would, transform how we live our lives and how we carry out the things that we do, okay? 1962, 50 years have passed, and we don't have that relationship with machines. So we're asking, why is this? Why are we in a state where we're still struggling with our machines? So let's look at that question and that problem a little bit more deeply. So today, you have engineers trying to build the world's smartest machines, machines that operate like brains. And you see all of the news stories these days about artificial intelligence, okay? Great. Those guys are making huge progress in doing those kinds of things. At the same time, you have biologists developing medications that are trying to make people smarter. Okay, great. Fantastic work that those groups are doing. What most people don't realize is that that's building a divide, okay? Doing pure engineering to make machines smarter or doing pure biology in order to make humans smarter. And the nature of the conversation today is about thinking about how we can change those trajectories. How can we get the best out of machines and the best out of biology to come up with a more intimate relationship with machines? Symbiosis. So when we think about doing that, we want to, again, leverage the best aspects of computing, the best aspects of biology, to ultimately allow these two types of systems to work together. Now, the thing that's very interesting about the word symbiosis is that most people think it's one thing, okay? They say, oh, symbiosis, I know what that is. Well, it turns out as if one studies natural history, you can figure out that it's not just one thing. It's actually a spectrum of things. And it ultimately has to do with how two organisms or entities interact with each other and how the fitness of those two things is changed through that interaction. And it can range from everything from pure competition, like the brown and green anole. These are two lizards that live in South Florida. I saw a bunch of these when I was growing up in Florida. Again, that interaction is not beneficial to both of them because they compete for resources. You have even things like the black walnut tree. Again, lives in its environment, thrives in its environment, but it produces chemicals from its roots that kill other plants that are in close proximity to it. Not so great, right? The part that we feel is most interesting about the spectrum of symbiosis is the far right-hand side, right? The part where commensalism and mutualism come into play. Thinking about how organisms interact to help their fitness, right? To promote their fitness. And these can be things like the oxpecker bird that lives on antelope. As the antelope walks through the grass in the savanna there, bugs fly up and those birds can eat those bugs, right? Gets a meal out of that, riding on the back. And there's also things like the clownfish and sea anemone, right? The sea anemone provides protection for the clownfish. The clownfish provides food for the sea anemone. So these things are great, and we can ask, why are those organisms enabled to have that mutualistic or commensalic kind of relationship? And it's because they have specialized organs that enable them to interact. They're in very close proximity to each other. They produce products that benefit each other. And ultimately, if we're going to be designing next generation systems that kind of overcome the problems of interacting with machines or even other humans, we say, how can we engineer systems to do more of the things like nature does here? Okay, so we're going to dive into that aspect in a little bit more detail. Okay, so let's look at two other very interesting organisms. Okay, so this is the goby fish and the shrimp. Okay, so the goby or the shrimp is completely blind. All right, and its only objective or role in the world is to not get eaten. Okay, and it's formed a very interesting relationship with the goby fish, who its only objective or goal in life is to live in a burrow. But it wants a clean burrow, and the sand keeps falling in there. All right, so these two have learned to interact with each other, and they interact in a very interesting way. The shrimp keeps one antenna pressed up against the belly of the goby fish. And as the goby fish moves, the shrimp is sensing when the goby fish is moving, and has a very dynamic relationship in order to deal with complexity in this kind of environment. They've learned to survive through developing this symbiotic kind of relationship here. And the interesting thing about that relationship, and it's kind of it's an important point. It's not the product of their interaction that's important. It's the process of their interaction that enables them to deal with complexity. Okay? So again, it's taken a lot of time for nature to figure this out, but they have done it, and again, provide some very beneficial kind of effects here. Now, let's kind of think back to humans and machines, right? Our relationship with humans and machines is nothing like that. Machines have no idea about our physiologic state. They have no idea about our stresses or strains. They have no idea about our goals and rewards, okay? They don't have the fundamental substrate in which to build that symbiotic relationship with us, okay? So again, the conversation today is how do we change that? How do we fix that relationship such that we can have this more close, interactive kind of relationship with machines? So let's use a very simple example in order to illustrate this, okay? Again, because this is a conceptually difficult kind of idea, but let's see if we can drill down to the most simple example to highlight some of the key elements or ingredients to make this happen. So temperature control, something all of us deal with every day, right? The ambient temperature in the room. If you think back to the 1950s, the kinds of machines that we had available to us to do, to handle the control in the room were simple thermostats, right? It's just a switch. And with those kinds of devices, we set it and forget it. It's like the Ron Popeil, approach to temperature control, right? Again, just set that temperature, very little interaction with the thermostat, and then hope for the best. And we know the consequences of doing that. The room temperature isn't controlled very well, right? And those thermostats, they actually do some crazy things sometimes. They'll turn on and off until they blow up your energy bill, right? Not so good. So people, after seeing some of the the problems with those kinds of interfaces, they said in the late 80s, early 90s, let's come up with programmable thermostats. And the mode of interaction with those thermostats is a little bit different, right? You can set temperature ranges, you can set time ranges, and those instruments have more intelligence and a little bit more interaction to help control the temperature in that room, okay? But again, problems with that. Try getting one of your family members to program one of those things. It's really tough, right? It's not very natural. Now, carrying these ideas a step further, right? How machines change in order to come up with this more interactive kind of relationship with the people that are using it. If you think about the Nest thermostat, it's looking at the temporal sequence in the increases and decreases of temperature that you're imposing on the system in order to get the optimal room temperature. Now this is more along the lines of the symbiosis concept that we're talking about, right? It's the interaction that enables you to do much more. Now, even with the Nest, is still missing a fundamental ingredient here, okay? So just think of this situation. Imagine you're on your treadmill in your house, and your physiology is changing because you're on that treadmill. That Nest thermometer is going to have no idea that the ambient temperature may not be optimal for that kind of situation. Likewise, when you go to bed, your physiology takes on a whole different state. And again, the Nest thermometer has no idea about that. So what if we change that interaction to say, instead of turning up and down the thermostat, what if the Nest had some fundamental idea about your physiology? And it could learn the states of your physiology and can interact with you in a very dynamic way in which to optimize the temperature. This is more along the lines of the symbiosis that we are working towards. Now, why is this such a powerful concept? Okay? It's a powerful concept because it means something when your vascular system changes and dilates. It means something when those dilations and contractions are coupled with, let's say, the sweat on your skin, and when it's coupled with your brain state, and when it's coupled with your heart rate. It means something. Think about the fight or flight response, right? When you have a threat in the environment and your physiology changes, the hierarchical representation of your physiology changes with respect to that kind of condition. But then contrast that to, let's say you're watching a video of a mountain climber on YouTube, your hands start getting a little bit sweaty, but it's not coupled with these other changes that may be happening in your body. A different reactionary kind of state, but again, meaningful in terms of how your body and your brain are responding. So the fundamental change that we need to make in terms of our interaction with machines is not only getting the physiology out, but it's helping machines to understand these kinds of aspects here, okay? And today, we are too focused on the aggregate activity, the outcome of our physiology, and not so much focused on the signals that give rise to that. And again, machines have no idea about the functional relationship between the two. So kind of the challenge that I'm presenting out to this community is, how do we build a software development kit for this that knows physiology? Right? It doesn't just report information back, knows physiology, knows the rules of the physiology, the dynamics of physiology, and can act against it. That's the challenge. That's one of the steps to getting us towards a more symbiotic relationship with machines. Now, why is this a good time to be talking about these kinds of things? Well, it turns out that there's huge advances in sensor technology. Okay? The quantified self. Everybody's building a sensor these days. But there's a challenge with that, right? Those sensors are not aggregated. They're not deployed in a, again, hierarchical way. They're not deployed in a way that's easily accessible. So the challenge for this community is, can you build the next generation sensors, again, in the near term, that would enable us to access this hierarchical kinds of information? Now, what if we think about the brain? Okay, so that's a more difficult challenge. And Sue Siegel, mentioned this a little bit. How do we non-invasively interact with the brain? That's another really challenging proposition, right? Either via electrical or optical or chemical kinds of actuation and signaling from the brain. We need huge advancements there. So again, that's another challenge for this kind of community. The second challenge for this community is, once you have those signals, what are you going to do with this? Okay, so we have great processors today. And I would even argue we don't need supercomputers to do the kinds of things that we're talking about here today. We can take our current generation kinds of processors and change the kinds of systems and the programming that we put on there in order to facilitate interaction and integration. Okay? And if we do that, all right, if we do that and get people out into the world and interact with machines in this very different way, we can make a fundamental shift, right? This is a pivot point. Stop building machines for one-off purposes and start building interfaces that facilitate integration and interaction between humans and machines. If you do that, it changes everything. You open up the possibility of building ecosystems where your physiology is not trapped in your body anymore. It can get out into the environment, and you can interact with that environment in a way that the environment acts as an emerging player, okay? And with that emerging player, you can change the way that you work, the way that you communicate, and the ways that you play, okay? So stop thinking about that one application and think about developing foundational technologies that change the way that our physiology interacts with the environment. Now at DARPA, we get to do a lot of fun things. And I've told you about natural history, right? How natural history enables us to think about symbiosis. I've told you about technology. We get to do all kinds of great things with technology. But the last thing I'd like to share with you that's fun about our jobs is that we also get to think about an aspect called design thinking. Okay, so it's not just saying we need to develop technology, for the sake of technology. It's about thinking about technology through the lens of the people that we serve. Okay, these are the military personnel, again, that you heard Jeff talk about, that have a life on the battlefield and have a life back at home, and thinking about how these new kinds of interfaces affect their lives. And we have two kind of prototype people that we think about Symbiosis with respect to. There's Danny, who was in the US Navy. We think about how her physiology could get out of her body and interact with very common things like mirrors that give feedback and could enable her to, again, interact with her physiology through that kind of medium, right? Mirrors are everywhere. This could be a very interesting way to think about Symbiosis. Or what about like a home buddy, right? This kind of intelligent system, this agent that can interact with your physiology and help you do the kinds of things that you want to do. We can also think about people like Brent, okay? Brent's from the Army. He was an explosive ordnance disposal. And Brent has issues with sensing where people are around him in the environment. He was injured in his service to the nation, can't turn around. What if we gave him a physiological interface that will enable him to use his sense in a very different way, right? Sense the person that's behind him. Or what if we enabled Brent to interact with the environment where he could use his point of view to control different kinds of devices? And again, those devices were responses to his kinds of physiology. Again, the list goes on and on here. But again, it hinges on that fundamental ability to get the physiology out and then to interact with the machines in a very interactive way, in an integrative way with them. Now, the last concept that I'd like to share with you is this one, okay? I can talk up here all day about the great aspects of this kind of physiology and talk about, conceptually, what these could do for military personnel. But I really want to drill down and think about how does this affect you, right? All the people up front, people in the back. How does this affect your everyday lives? And what I'm claiming to you today is if we start building interfaces with this new perspective, we change devices from being tools or objects to agents that we interact with. And those agents can help you to understand your physiology. They're aware of your physiology. They can help you give you feedback about that physiology. But again, not just the numbers associated with your physiology, but what you actually do with your physiology, what it does in the world, what it does with respect to others in the world. And ultimately, we really feel that these kinds of physiological interfaces can help you be the best person that you can be. Right? It can help you to achieve your goals. But because it has fundamental understanding of what your physiology is doing, it can also call you out on your bull. So thank you so much.